All right, guys. Yes, my selection here is getting pretty weak, but all right, guys. So 5-3, we're still solving. We're just adding a few more twists to it. So our directions, now we're going to say solve, but we're going to find all solutions. The word all is important in your directions there, okay? We're going to start with sine of 2x equals negative root 3 over 2. All right, so sine of 2x, you could use a double angle identity in here and substitute, but it's actually going to just make the problem more complicated for you. And that method won't work if it's, say, sine of 3x or sine of 4x or, anything above a 2. So I'm going to show you another method that will work no matter what the angle is, whether it's 2x, 3x, 4x, okay? So off to the side here, we're going to rewrite this just as sine of theta equals negative root 3 over 2. So go back to just a basic equation. So if we're thinking just our unit circle, where does sine equal negative root 3 over 2? What are the two angles where that happens? Do we know, guys? Where is sine negative root 3 over 2? And 5 pi over 3? Yes, I heard both of those. So 4 pi over 3 and 5 pi over 3. Okay, so far nothing new. That's just knowing your circle. But our equation didn't start with just theta. It had sine of 2x, okay? So we've essentially replaced the 2x with a theta. So we now have to solve that. So what I'm going to write is 2x equals 4 pi over 3, and bear with me on this, we're going to write plus 2 pi k, I'll explain in a minute, and 5 pi over 3 plus 2 pi k. So what we did from the red problem over here, we went ahead and we let theta equal 2x. Are you guys okay? Like, that's the substitution we started with. That's why I'm now saying 2x equals these things, theta equals. Okay, the plus 2 pi k, that's the weird part here. The direction said find all solutions. We know one time around the circle's 2 pi, right? 2 pi k means go one time around the circle, 2 times, 3 times, 4 times. It gives you every answer if you kept going around the circle over and over and over. Okay, that's the notation when you see all solutions. So when the directions have this all in it, that means there will be a k in your answer. All right, and we have one step left in solving this problem. Right now it says 2x equals this big mess of values. We want to know what x would equal. So how do you think I'm going to solve this equation for x? Yeah, divide everything by 2. Literally all of this we're going to divide by 2. So what is 4 pi over 3 divided by 2? Okay, 4 pi over 6, which is really the same as 2 pi over 3. There we go. And then plus, it's not going to be 2 pi k anymore. What will it be? Pi k, good. And then 5 pi over 3, what will that become? Good. Plus pi k. All right, that is your answer. Looks weird, but it's not that hard. That was fun. Okay, good. You knew what you were doing? You could divide with fractions. That's always good. Questions on that one? We're going to do several more, but just any issues there? Okay, let's try again. Let's try this time cosine of 3x equals 1/2. Same directions, find all solutions. I'll let you guys try this one, okay? Mm-hmm.
Would you add 2 pi k or 3 pi k?
Always 2 pi k because it's the distance around the circle, which is 2 pi. So good question. Yeah. Check in with each other, see how you're doing. What's up? Mm-hmm. It's okay.
I'm so tired. My brain is like mush.
Yeah, it feels like the gears are a little slow today, right? Like it's just nothing quick is happening. We're creaking along here.
Yeah, I got that wrong.
Are we ready, guys? All right, let's look at this one. Okay, guys, so off to the side, I would think about just cosine of theta equals 1/2. So where does that happen? Where does cosine equal positive 1/2?
Pi over 3, pi over 3.
Good. Pi over 3 and 5 pi over 3. Okay, good. All right, so what I have to do over here then is set the 3x, the angle in here, right? That's what we said could be theta, equal to pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. And again, guys, why am I putting that plus 2 pi k? What in the directions told me to do that? All solutions, yes. Okay, then divide everything by 3. And we have some lovely answers here of pi over 9 plus 2 pi k over 3 and 5 pi over 9 plus 2 pi k over 3. How did we do? Got there? Okay, okay. So questions so far when it says all solutions. And even if it didn't have the weird coefficient on the angle, if it was just, you know, if it had just been this problem and said all solutions, you would still do the plus 2 pi k there, okay? So anytime you see all solutions, you'll have a k in your answer. All right, new twist. Now we're gonna solve, back to solving just 0 to 2 pi. Okay, but we still have the coefficient with the angle in there. So I've got cosine of 3x equals 1/2. Very similar to the problem we just did, right? We just did cosine of 3x equals 1/2. But all solutions is different than 0 to 2 pi. Okay, you start the same way. And I know we just did this, but we're going to do it again. So cosine theta equals 1/2. We know that's pi over 3 and 5 pi over 3. Okay, I'm going to go over here. Again, the exact same thing. 3x equals pi over 3. I'm still using the plus 2 pi k. It won't end up in my answer, but we have to use it along the way. So plus 2 pi k, 5 pi over 3 plus 2 pi k. So same process so far. Divide everything by 3. Pi over 9 plus 2 pi k over 3. 5 pi over 9 plus 2 pi k over 3. All right, that's not my final answer though. If it had said all solutions, we'd stop there. It says solve 0 to 2 pi. That means I need to know the actual angles between 0 and 2 pi that meet what this says, that are the pi over 9 plus 2 pi over 3. So the way you start, the first answer is pi over 9. To that answer, you are adding that 2 pi over 3, okay? you are actually going to do this little problem right here. So off to the side, if you need to write it down to figure out your fractions, I am just adding those together. Pi over 9 plus 2 pi over 3. How do I add fractions? Common denominator. So this is really pi over 9 plus 6 pi over 9. Yeah.
Comes to the K.
So we're only, the K means like repeat the value over and over. We're using a single 2 pi over 3, and then we'll use another one after this and keep going with it. So guys, when I add pi over 9 and 6 pi over 9, what do I get? Okay, that's my second answer. I then have to add again. So to the 7 pi over 9 that we just found, what do you think I'm adding? Yeah, the 2 pi over 3, which is 6 pi over 9. So when I add again, what do I get? So again, let me write it off to the side here just so you see what we're doing. So now I'm taking the previous answer and adding the 6 pi over 9 to that. So we get 13 pi over 9. Okay, do you think I should add again? Okay, why not? You're right, but why not? It would be bigger than 2 pi. If we add it again, we would get 19 pi over 9. Okay, 18 pi over 9, that would be the barrier for 2 pi. Okay, so we don't want to add again. But we do have this whole other set of answers to go deal with. So my next answer, I'll move on now to the 5 pi over 9 part. So 5 pi over 9 is my next answer. How am I going to find the answer after that? Yeah, add the 2 pi over 3, which again would be 6 pi over 9 if I did my common denominator here. So 5 pi over 9. We're adding the 2 pi over 3, which is really 6 pi over 9. So what do I get when I add those? Good. All right, I'm going to add one more time. What will I get when I add one more time? 17 pi over 9. And again, is everybody okay with why I know I'd stop there? Like I'm not going to keep adding after that. Okay, because it'd be bigger than 2 pi if I added. All right, so those are your answers. We obviously like the all solution directions better than the 0 to 2 pi directions, right? Now, kind of a guide for you. When we solved this initially, over here we got 2 answers, right? And then my coefficient here was a 3. What is 3 times 2? 6. And how many answers did I end up with at the end? 6. So it's changing the period of the graph, making it happen 3 times as fast. So you're going to get 3 times as many answers by the time you get to 2 pi. Okay? I'm not going to make you graph any of these, but that's essentially what you're doing, is you're thinking of the graph like, oh, it has tripled with how quickly this is happening. So you're going to have 3 times as many answers. Okay? We obviously need to practice more, so let's try again. Questions before I write the next one? Right. Let's do sine of 2x equals -1. I want you guys to try this one. I will absolutely walk you through it too, but I want you to try it to see if you can get there, okay? And again, this is 0 to 2 pi.
Oh, yeah.
The pi. Yeah. Oh, so you could subtract 2 pi k, but it's not going to get you 0 to 2 pi for your answer.
It will be, answer, I will be like bigger than 5K so that if you were to subtract it, it would still be integral.
So yes and no. Like you might have some that are so big that you're thinking, oh, maybe I should subtract. But subtracting is going to change what's actually happening, and it's going to give you an answer that's not really the answer we want. Okay, so you're always just going to add. Yes, keep it simple. The only time you wouldn't is if I did something weird and said like, solve from -2 pi to 0, you know, and gave you like a weird window to solve. But I'm not going to do that to you. But that's when you'd be like, oh, I have to go backwards. I have to subtract. Okay. We will stick with 0 to 2 pi. Definitely check in with each other, guys. See if you got it. Okay, so we're okay. That's good. So you did the process, right? Okay. I like So I think so we don't. All right, guys, let me go through it. Lots of you are doing very well with this. So off to the side, I would think about when does sine of theta equal -1? That only happens in one spot, okay? That only happens at 3 pi over 2. So guys, right from this step, do you know how many answers you should have at the end? 2, okay, good. So then I'm going over here, 2x equals 3 pi over 2 plus 2 pi k. Divide it all by 2. Get 3 pi over 4 plus pi k. So my actual answer, I start with 3 pi over 4. When I add pi to that, I get 7 pi over 4. And that's all I can do. And you knew you should have 2 answers, so that's where we stop, okay? All right, let's do one more, guys. I feel like I've forgotten when class ends. Like, don't know the times. We're good. We can do another. 16, yes. Well, and then I had to look at the clock. I was like, wait, is my clock right? Or did the power go out? Or did... We're good.
Ours says it's 10/11 in 2002.
Oh, dear.
Like, as soon as it's like a new year, I guess, screwed it up because it's so old. I guess they just
It just can't handle it. Yeah, that's pretty funny. All right, guys, try this one for me. So realize x over 4, that's like 1/4 x, okay? Start the same way. Over to the side. That's where you begin, okay? I'll give you a few minutes to try this one. Last one we're doing in our notes.
Are we solving within or like solving?
Yes, you are solving 0 to 2 pi. It's good that you're noticing something.
If anyone could call on.
Oh, it's fine. I thought it was cosine. No, it was me.
Exciting if you did.
What they call it.
But yeah, I was looking at the premise already. Already more.
It's a weird one.
Yeah.
Yeah.
I've already over.
Are you guys noticing anything weird with this one? All right, let's go through it. It is strange because of that 1/4. So first I'm going to start where does sine equal -1/2. So guys, where does that happen? Are we at 7 pi over 6 and 11 pi over 6? We okay with that? Okay. Now, when we go over here then to solve this, we've got x over 4 equals 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. How do you solve this? Multiply by 4. That is making some large numbers, right? Okay, 7 pi over 6 times 4. What do we get there? 14 pi over 3 and plus 8 pi k. All right. Is 14 pi over 3 bigger than 2 pi? Yeah, and clearly adding 8 pi to something is going to make it bigger than 2 pi, right? You can multiply the next one, but 11 pi over 6 times 4, isn't that also definitely going to be bigger than 2 pi? Yeah, so what does that mean for this? No solution. Okay. Now, the reason that happens, you know, we had a 1/4 essentially in front of our x. So when you take 1/4 times your two answers, you get half an answer, right? So that means you might have one answer or you may have no solution. It just depends on what direction the graph is going and what you're solving for. That b value being 1/4, remember from your graph, it means it happens, you only see a quarter of the graph by the time you get to 2 pi. So if that quarter of your graph happens to intersect with -1/2, you'd have an answer. Our quarter of the graph does not intersect with -1/2, so we have no solution. Okay? How we doing, guys? Okay. I just assigned the MathSpace homework to you for 5-3. Now, I still need to go back into MathSpace and update the due dates on all of those second attempts because obviously your test got moved. So I will definitely change those. The homework on MathSpace for 5-3, it's going to say give the general solution. The general solution means all solutions. So when you see general, that's the same as all solutions, okay? And I think MathSpace has you use an N instead of a K. It tells you in the directions what variable you should use. But your homework, I believe, is all general solution kind of problems. So that will be an easier homework assignment, okay? It won't be the actually adding the fractions. So you've got a little over 15 minutes here, guys. You could start on that. You can work on second attempts. Again, I'll update the due dates. So let me know if you have questions. Yeah.